Hello everyone. Class 12th, topic name Nature of C-X bond in haloalkane. As well, we already know what are haloalkanes. Alkane hydrogens are getting substituted by halogen atoms. The organic compound is known as haloalkane. Now, in this topic, we are going to discuss about the nature of C-X bond. Means, suppose we have this haloalkane with us. Chloroethane, 1 chloroethane. So in this topic, we will understand what is the nature of this part. X is representing halogen over here. So X can be fluorine, chlorine, bromine or iodine. So let's try to understand what is the nature of this part. To understand the nature of CX bond, first we need to understand between C and X which bond is available. Between CX and X, it's a sigma covalent bond. And this topic, sigma covalent bond, pi covalent bond, we are familiar from 11th class. This topic was present in 11th class, so no need to discuss how sigma bonds are formed between C and X. In this bond, one unpaired electron is of X and one unpaired electron is of carbon. Those electrons are getting shared by both. Now, one concept of the chemistry which we call electronegativity is always available in the molecule. What is electronegativity? Electronegativity, the power of an atom to attract shared pair of electrons. The power of an atom to attract shared pair of electrons. Between C and X, electronegativity of X is more. So what will happen? Both electrons will get shifted toward X. Because X electronegativity is more. X can attract electrons better as compared to carbon. So what will happen? These two electrons will not remain longer in center, like they must be here in center. But due to high electronegativity of X, this pair of electron will go little toward X, due to which there will be the charge separation over here. Because out of these two electrons, one electron is of carbon and X is attracting that electron. One electron is of X and one electron is of carbon. Now X is attracting extra electron of carbon. So X will get extra negative charge, partial negative charge. Now because carbon is losing its electron toward X, so same amount but opposite charge will develop on carbon, means partial plus 1. This partial word represents little bit distribution of electron, not complete transfer of electron, little bit transfer of electron due to electronegativity difference. Now due to develop of these charges, negative and positive, the molecule will become polar in nature. Yes, poles will be developed. You can check carbon is getting a positive pole and X is becoming a negative pole. Means your CX bond becomes polar in nature. That's it. This we were finding, like what nature of C-X bond is there. Between C and X, there is a sigma bond, and in sigma bond, 2 electrons are involved. Now we have to understand electronegativity. Electronegativity is the power of an atom to attract shared pair of electron. X means fluorine, chlorine, bromine, iodine will have more electronegativity than carbon. So what will happen? These 2 electrons will get shifted toward X, due to which X will get extra partial negative charge, and carbon is losing its electron, so it will get extra positive charge. Now positive pole, negative pole means the C-X molecule or C-X bond becomes polar in nature. Now in next video, we will understand bond enthalpy, dipole moment in C-X bonds. Thank you very much.